Being not members of classification community, we're just simple users of classification, we'll try to offer you and discuss with you a large class of objects, of soil objects, which to our mind and to the best of our knowledge are underrepresented in the classification discussions and considerations. So, usually you deal with the normal soil profiles developed in unconsolidated, loose materials with all the development of diagnostic features which you consider your classification. However, there is a large class of objects formed on the surface of the lithosphere in the contact with the climatic and biotic factors, which are solid rock surfaces. They are quite common, of course, especially in the mountainous geosystems, but not only, you can find them also in the plains, in the temperate area, humid areas, in the regions affected by geologically recent, late Pleistocene glacial erosion, like in Scandinavia. Also, they are common in the extreme desert environments. Solid rock surfaces, however, have their own features and properties related to interaction with the climatic and the biotic factors. They are colonized by various organisms, mostly primitive, in the range from bacteria to lichens. And also they present quite a complex set of features related to alteration, weathering of primary minerals, precipitation and accumulation of secondary products, like, for example, these carbonate, carbonate crusts. Also developed quite complex systems like weathering rings without losing the consolidation and this hard state. They still not transformed into loose soil material. Soil scientists, since long time, are aware of such kind of objects, and there is quite a bit of research done about it. For example, this study by Nikita Mergelov and co-authors on Antarctic, what they called endolytic soils, weathering rings, which show very complex population of microorganisms, and also a complex set of processes which we could consider pedogenic, not only transformation, etching, dissolution of primary minerals, but also even small alluvial profile with something like bleached horizon and horizon of accumulation of iron oxides, all in the solid material. These are not unconsolidated, loosened substrates. Human impact, to my mind, enhances and increases a lot the landscapes with hard rock surfaces. Due to erosion of soils, in the mining landscapes, a lot of fresh rock surfaces appear, but also urban landscapes. Maybe we could consider them as predominantly solid rock surfaces, some of them natural and some of them artificial. Also, these artificial human-made rock solid surfaces interact with the environment and produce crusts, pendants, rings on the surfaces, but these objects are mostly out of the scope of pedology. They are studied by specialists in biodeterioration, related to, for example, problematics of conservation and restoration of historical buildings. But look, the features which appear in these surface objects also look quite familiar for us. For example, this neoformed calcite of acicular or fibrous type looks like soil neoformation. Dr. Monga will check what I'm saying in this regard. So, are these objects soils, and especially are these objects somehow should be subjected to soil classification? There are some theoretical works about it, and terms like incipient soil, endolytic soils, primitive soils are applied. I would like to present here this work of Goryachkin and Sergey Goryachkin and his co-authors, among them Viktor Tergulyan, whom you all know, of the general classification of the objects which appear on the surface as a product of interaction of the environment and the lithosphere, and these crusts on rock surfaces appear here under the term of mini-soloid. In this range of dimensions, much smaller than normal soils, but still with quite characteristic set of pedogenetic properties. I put this example here because maybe we could consider it as a further step of development of the Kuchayev concept, which was presented so nicely by Erika. But this is the general viewpoint, and what about classification in particular? I think that within the scope of this idea of epiderm of Earth, these kind of bodies could also enter into classification scope because they in fact fit to many of these demands expressed here as the definition of the object of soil classification. We could talk about multi-phase system, about some structures, and about the constantly evolving objects. I will try to prove it considering a very specific type of this rock crusts, desert varnishes. I think you are ever aware of this kind of objects. I am sure you saw some of these varnishes in your trip in the northern Mexico. They are widely spread in the desertic, but not only desertic systems. For the first time, it was described by Humboldt in Colombia, in quite moist environment. But mostly we find them in the deserts, both hot deserts and also most cold and dry deserts of Antarctic valleys. Interesting aspect is that these objects appear not only on the Earth's surface, but also on the other planets. Now the mission of Curiosity documented them on Mars' surface. And look how similar there on Mars they look, being compared with the desert varnishes of Sonora. So desert varnish as possible object for soil classification. I will quickly try to present our case study. This problematic of development of varnish on Mars brought to us our collaborator, Dr. Pavel Martinez, who is now doing with us his postdoc stay. And here I present mostly his results. So, Sonora state in the northwest of Mexico, mostly semi-desertic environment. So-called Sonoran Desert is, in fact, quite vegetated ecosystem or biome. Rock surfaces are quite common here. In this case, the parent rock will be Mesozoic granite. And something very characteristic of the site which we studied is presence of petroglyphs carved on the varnished rock surface. It has very interesting consequences. First, we could consider this soil object, if we decide that it is soil, as an important natural resource for ancient communities, resource for artistic activities. But I showed it mostly for the other purpose. These petroglyphs gives us a very interesting chronological marker. The oldest of them are of archaic age, several thousands years ago, so they were made in the middle Holocene, 5,000 to 7,000 years ago. Means that desert varnish, which seems to us so ephemeral, so thin feature, was already present 7,000 years ago on this surface. And these petroglyphs are not repigmented. So the process of the formation of varnish is very slow. It did not manage to cover these petroglyphs during 7,000 years. It is something related to our discussion with Cesare, that on oldest land surfaces in Pamir, desert varnish appears. So maybe it fits to the idea that it is slowly evolving system which is demanded for the object of classification by WRP. Now, sorry, I forgot to tell you about this dating. Pavel Martinez managed to accumulate enough varnish material to date it with radiocarbon. Content of organic material of organic carbon is very low, but it was enough, less than 1%, but it was enough for IMS dating. Look how young it is, much younger than petroglyphs, just 3,000 years, 4,000 years ago. It means that organic materials in these objects is quite new, and some life is proceeding in this quite old system. So this varnish is host of recent biological activity, is a habitat for some organisms which produce organic materials. We managed, with the participation of soil and geobiologist Rocio Alcantara, to make some investigations of genetic materials from these substrates and obtain some idea of bacterial and archaeal population there. And it resulted that diversity is quite big and comparable or even higher than in the soils of the surrounded areas. So in terms of biodiversity, this is also quite a developed system. What is its composition? Look at these micromorphological images. This is the coating of varnish on the rock, on the granitic surface. It's quite variable thickness, but mostly less than 1 millimeter, sometimes thicker, especially above the ferromagnesian minerals, sometimes thinner and penetrating into rock along the planes parallel to cleavages in the feldspar grains. Sometimes it has such a very complex botryoidal surface. Very interesting thing. Coating of varnish itself does not contain fragments of primary minerals that cast doubt on the idea that it is a weathering product. It is just uniform coating or strongly pigmented with iron and manganese. Under electron microscope, we can see very interesting features, in particular these polygonal structures on the desert varnish surface and its laminated character in the cut. Under even higher magnifications, we see its globular arrangement. Soon we will finish. I just want to draw your attention to the fact that not only iron and manganese are here, there are also some silicate material, silicon and aluminium. These are clay components which make up to 70% of this material. What kind of clay it is, we still don't know. But at least we have an idea how to approach this problem. It is very interesting, already also speaking about the origin of this coating, that it is very similar at different rock types. We made a study of this coating at different geological materials in the north of Mexico, and despite their contrasting difference, the composition and structure of these coatings is very similar. So this is the model of the origin of desert varnish, mostly related to airborne particles, not to the rock substrate. Very complex model. You must remove major part of this aeolian silt to produce this desert varnish. Anyway, this is dominant model for the moment. So this we can see, if we decide that this is a soil, we must say that it is a sedimentary soil, not normal soil formed from parent material below. It has also certain paleoecological significance. There are very interesting studies about this, so we could put forward the question if desert varnish is a paleosoil or paleoecological object. And finally, relation to the classification. Cesare told us that it is part of aridic qualifier, yes? But its composition, iron and manganese, it is so distant from our idea of arid pedogenesis. Arid pedogenesis are carbonates, salts, gypsum. To my mind, most close objects or diagnostic elements of WRB are these diagnostic horizons and maybe these qualifiers. Sorry, my finger covers all the space here. And these qualifiers, especially classical qualifiers. Now, great problem is that all these horizons, these qualifiers are related to redoxymorphic processes, which are practically impossible on these well-aerated rock surfaces. With this question mark, I finish, and thank you very much for your attention.
Thank you very much, Sergey. This was a real good excursion to a topic we normally don't deal with. Thank you very much. Time is advanced. There is only the possibility for one, let's say 2 questions. So, Carl and John. Yeah, please. Carl, please.
Okay. Thank you for this nice presentation. Okay, I can try also with. Okay, very nice presentation. But for me, it's totally clear. This is a soil formation. There's no problem at all because we have water involved. we have the rock involved, we have biology involved, and I have observed several desert varnishes in Egypt, in Somalia, in the south of Israel, and there was always clear that is related to the age of the surface. So when we have terraces, for example, in eastern Somalia, the youngest terraces then 2,000 year terraces have a soft varnish, and the old terraces have a very strong varnish there. And what you also mentioned, soils with soluble materials, with gypsum and with calcium carbonate, they change too quick and they cannot produce a desert varnish. But anyhow, it's a soil formation.
Then how to classify it, Dr. Starr?
Sorry?
How to classify it?
Well, you had the terms already there, but I would insist that it's a varnish. So we must separately, talking it ferric or also is not nice. It could be a pen. It could be a pen.
Thank you. My very interesting presentation. Thank you. My question is not so much related to the classification as it is to the genesis. I'm just curious, in these areas that you studied, did you ever find an indication of these genetic processes taking place on the soil surface rather than the rock surface?
Thank you very much for this very interesting question, and question really corresponding to our area of research. We started our investigations in Sonora, mostly on paleosols there. And speaking about processes like accumulation of iron oxides, rubification, we detected it in the specific paleosols corresponding to the terminal Pleistocene, about 40,000 years ago, which show these features. Of course, not such high accumulation as in desert varnish. But anyway, some pigmentation with iron oxides and some redoxymorphic features in the lower part of the profile. So there is a quite developed hypothesis, especially in southwest of United States, that desert varnish is mostly a relict feature from this terminal Pleistocene humid period. Well documented in other records like paleo lakes, packrat meadows, and so on. Maybe we could share this hypothesis. However, process of varnish development goes on, also in the Holocene. How it is possible in quite arid environment?
Thank you very much, Sergey. Thank you to all the presenters. Thank you to all the contributors. We are now half an hour late, so I would like to conclude the morning session. Erika, you have something very good.
I wanted to share a joke. You let me do Sergey's presentation. Very quick. Okay, so when we were in the forest and the policeman came, you remember, we got free. There was no problem because we told we are looking at the soil. But can you imagine if we were in that site and the policeman comes and we tell that we are looking at soil? Perhaps we would be, perhaps we would have ended up in prison.
Okay, so we meet again at 3 o'clock sharp. The keynote presentation given by John. Then we have 2 more presentations, and then the meeting of the commission. Everybody invited. Are there special announcements in this room? Yes. Are there special announcements for the lunch break from the organizers' side?
Not only the options for eating is upstairs. There is the cafeteria of here of UNAM, and also there are some restaurants nearby. Sorry. The options for eating is upstairs, the cafeteria of UNAM here, and also there are some other restaurants nearby.